Hello everyone, myself Shifat Aziz. Today I'm going to discuss about the process of welding for joining two dissimilar metals. The specimens I have is grip resistance 2.25 chromium molybdenum steel and another one is ASI 310 steel. So in many metalworking industries, different metals for operates at a different temperature. So the specimen we have is simply known as austenitic stainless steel and another one is ferritic stainless steel. Austenitic stainless steel is very much popular in high temperature applications, and ferritic stainless steel is usually for low temperature applications. So in this research, I'm going to find a process to combine both the materials together, which is definitely a challenging job, which leads to a research question: which way is the best way for joining two dissimilar metals? So basically, we need to find some problems in this process. So the most important problem is what are the actual problems we are going to face in the welding process. And because this is a steel metal joint, so definitely crack will form. And in this research, I try to find the solution of this crack formation problem. So in this research, I searched for previous experiments which are already done in this area for joining two different metals. So from my research, I have found that there is a thermal expansion variation in both of the materials, which is really a big problem. And creep failure really occurred in the heat affected zone, and in the wild areas of zone and hard zone is created, and the non-uniform micro hardness in wild area is also produced. And the most interesting thing is plastic deformation just occurred before the final failure of the joint. So in residual stress is also responsible for the crack problem in the joint. So from my research and among different welding process, the quality of the joint by friction stir welding is higher than tungsten inert gas welding. So why the weld joints fail? So basically there are three main reasons. The difference in mechanical and metallurgical properties of the metals, the coefficient of thermal expansion difference, and the residual stress. So for to join both the austenitic and ferritic steel, I chose friction stir welding. There is some reasons behind that. The first reason is high energy density, uh, and and the most important thing is cost effectiveness. And finally, the friction stir welding gives the strong metal joint. So in my research design, I followed this structure. The friction pressure was 150 megapascal and rotational speed of the tool was 1500 rpm. And for my research, because there is thermal expansion imbalance in both of the materials, so I used filler metal, which is Inconel 82. And after the welding, I run some tests like microscopic test, Beaker test, and X-ray diffraction test, test for residual stress identification. And some visual examination was done when I ran the experiment, and some of the important visual examination was weld metal flow, metallography, how is the bed shape, and how is the microscopic cracks, and how the weld behaves. So what are the advantages of friction stir welding? In my opinion, the first and most important advantage of the friction stir welding is cost effectiveness. And other advantages are high strength metal joint, high pitting corrosion resistance, favorable fusion zone, high welding speed, and lot more. So in my research, I found one most important advantage about friction stir welding is crack formation in the weld area. So this problem can be overcome by using filler metals, and in my research, I did that, and the outcome was really good. So the whole process is carried out in titanium chloride reduction reactor, so there is no chance of oxidation, and the coefficient of thermal expansion is reduced by adding filler metal in between of the two dissimilar metal. After the joining process, X-ray diffraction tests were done in the metal to study the microstructure of the joint and to find out the soft and hard zones of the joint. Finally, I'll conclude that friction stir welding is the possible solution and the best solution to join two dissimilar metals. Here are some references that I use for my research, and thank you all.